In this example, we need to find the derivative of x equals e to the xy plus cosine y squared. We should quickly realize that this is a lot different than most of the questions we look at, since it's not solved explicitly for y, which means we have to use implicit differentiation, which means differentiating both sides with respect to x. So the derivative of x is 1. That's equal to the derivative of e to the xy is e to the xy multiplied by the derivative of xy, which is a product. So the derivative of x is 1 multiplied by keep y plus keep x times the derivative of y, which is y prime. That's plus the derivative of cosine, which is minus sine of y squared, multiplied by the derivative of y squared, which is 2y y prime. Now we need to solve for y prime. So to do that, we need to expand a little and collect the y primes on the left hand side. So that gives us negative x e to the xy y prime. That's this term multiplied and moved to the left, plus 2y y prime sine of y squared. That's this term moved to the left. That has the equal, well, everything else goes on the right, so this piece here will stay on the right. That's e to the xy times y, and this 1 comes to the right, so that's minus 1. Common factor, y prime, so it's going to come outside, and what's left inside will be divided on the right, so that leaves us with e to the xy times y minus 1 over all the pieces that are left here when we factor out the y prime. And we'll change the order just to make it look nicer. So that's 2y sine of y squared minus x e to the xy. And that's the final answer. As you're working through, you might want to include a couple of extra steps to make sure you're not confusing the algebra, but ultimately that's the result we need, making sure we solve for y prime.